Hello everyone, I welcome you again to the third video on the series of lectures on Introduction to DBMS. In this video, we will learn about data models in database management systems. So what is a data model? A data model defines the structure and organization of data inside a database. That is, how data is organized, how it is stored, and how it is related inside a database. A data model actually acts as a blueprint that guides the design and implementation of a database. So just remember the keyword blueprint. Different applications, they require different ways of organizing the data or storing the data or relating the things inside the database. Therefore, several data models have been developed over time. So here are some major data models: hierarchical model, network model, relational model, object-oriented model, and entity relationship model. So in this lecture, we will understand each of these models along with their characteristics and applications. Let's start with the very first type of data model, that is hierarchical data model. The hierarchical model organizes the data in the form of a tree structure. So it consists of one root node followed by some parent and the children nodes. If this is the parent, so these are the children. So a parent can have many children, but a child can have only one parent. So here you see the clients or the classes or the ASIO, ANSYS or Adobe. These are the children. They have only one parent, that is software. Similarly, the security or the SAM, hardware, right? So these things are the children which have a common parent called HKey local machine. So you see a good real world example is the Windows folder structure in your computer. So you open one folder, then you have n number of folders. You open another folder, then you have n number of folders inside that folder. Or the Windows registry you can see over here, where every folder or the registry key belongs to only one parent. So these are the three important characteristics of a hierarchical model. The first is it supports one-to-many relationship, meaning one parent can have many children, but each child can have only one parent. The second thing is there is a single path, that is from the root to the path which is covered. You come to any record, so there is a single path. So this makes navigation straightforward, you see. So the third characteristic is there is a deletion dependency. That is, if a parent record is deleted, all the child records, they are also deleted. Suppose when you delete this software, all these children will also get deleted. Thus, the hierarchical model is simple, it is efficient for representing hierarchical data, but it is not suitable for very complex relationships where the record needs multiple parents. So what is the solution? We go to another model which is called the network data model. It was developed to overcome the limitations of the hierarchical data model. So instead of one tree, we have the graph where a record can have multiple parents as well as there can be multiple children. So in the example shown over here, in certain XYZ university, we have different departments. For example, we have physics department, we have maths department. So a student can be connected to multiple departments. And then you have the library. So the library can be shared by different departments. Now, coming to the main characteristics, so it supports many-to-many relationship, where a parent can have many children and a child can have many parents. The second characteristic of a network model is there can be multiple paths. So a record can be reached through multiple paths. For example, if you want to reach library, so you can come via this path, or you can come via this path, or you can come via this path. So there are multiple paths. The third characteristic is it has got flexible structure. By this I mean that a graph structure provides greater flexibility in representing complex real-world relationships. So because of this flexibility, the network model, it is useful in applications such as transportation network, in telecommunication systems, and social network. However, designing and maintaining this model, it is quite complex than the hierarchical model. Next, we move to the object-oriented data model. So the object-oriented data model, it stores the information as objects. So similar to the object-oriented programming language like Java or the C++. So the object contains both the attributes as well as the method. So these attributes, they actually represent the data, while the methods, they represent the operations basically that can be performed on that data. For example, if you see a student object, so it contains attributes such as student ID, name, or date of birth, or email. Along with it, we have got some methods like enrolls, drop course, or view schedule, right? Similarly, course and teacher, they also represent the objects which have their own attributes and methods. Now coming to the characteristics. So the first characteristic is data is stored as object. The second characteristic is encapsulation, where data and methods, they are basically combined as a single unit. The third characteristic is it is well suited for handling complex data, such as multimedia, engineering designs, and scientific applications. So although powerful, object-oriented databases, they are generally used for specialized applications rather than just conventional business databases. So having learned about object-oriented data model, we will now move on to relational data models. A relational data model is the most widely used database model today, and it organizes data into tables. So where the rows, they represent the records, and the columns, they represent the attributes. So these are the records and these are the attributes. So in this example, we have student table and department table. The student table, it stores the information about the students, while the department table, it stores the department information. These tables are connected with the help of certain keys. So the primary key, such as serial number and department number, they help in identifying each record uniquely. For example, in the student table, serial number is a primary key which helps in identifying these records. While in the department table, the department number helps in identifying each of these rows uniquely. The foreign key is that column that refers to the primary key of another table, creating a relationship between these two tables. So these two tables, they are connected with the help of foreign key. The major advantages of a relational model are data is stored in the form of table. Relationships are maintained using the primary and foreign keys as discussed, and data can be easily inserted, updated, deleted, and retrieved using structured query language. So because of its simplicity and efficiency, almost all the modern database systems such as MySQL, then Oracle, SQL Server, and PostgreSQL, they are based on a relational model. Finally, we will study about the entity relationship model. The entity relationship model, or the ER model, it is used during the database design phase. So unlike the relational model, which we saw in the previous slide, so this model does not store the data. So what does it do? It instead provides a graphical representation of the database structure. As you can see from this diagram, it is exactly the same example that we saw in the relational model. We have two objects, student and department, and they have certain characteristics. Here we have three main components, which are the entities, which are represented by a rectangle, then attributes, which are represented by ovals, and the relationship represented by diamond. In this example, student and department, these are the entities which are connected with the help of certain relationship, which is called as enrolls in here. Attributes such as serial number, gender, name, phone number, department number, location, and department name, they describe these entities. For now, we have seen that in ER model, it is entity-based design where data is represented using entities, attributes, and relationships. The second point is diagram representation. That is, the relationships between entities, they are shown using ER diagram. Lastly, we have seen that it's about the database blueprint. So ER model is used for designing and planning the database before implementation. So in this slide, we will see the difference between the two important data models, that is relational model and the ER model. We have taken exactly the same example. In the relational model, you can see we have the student table and the department table, while in the ER diagram, we have the student entity and the department entity. Let's see certain difference between them. In relational model, it is difficult to directly visualize the relationship. So you can see here we have defined the relationship using the foreign key, but it is difficult to identify. But in the ER model, you can clearly see the relationship between the student and department connected via enrolls in a relationship. Next difference is the relational model, it contains detailed structure. That is, it has details about the data in the form of rows and columns. Then we'll have keys and records. But in the ER model, we don't have the detailed information. So how many students are there or how many departments are there? That data is not clear. So it's a high level overview of the database design. The third difference is relational model is more technical and it is used for actual database implementation. Because I have said that data is stored in the form of tables, and relational model is exactly the same representation of the database. But in ER model, it is easier for the beginners and designers to just understand how your database is going to look. So that is all for today's lecture. I'm eager to tell you about these two models in detail in the coming lecture. So stay tuned. Thank you for joining.